In this video, we're going to talk about how cross multiplication works. We use this in ecological population sampling, and it can be used in math and other areas. So let's just go over this a second. I'm going to start with a blank screen here. See if this works. All right. So one of the assumptions about cross multiplication is that if you're working with equivalent fractions, you can do cross multiplication. So you can't start off and say if you don't have equivalent fractions, right? Well, this doesn't hold up, right? 1/2 is not 3/4. Okay, so that doesn't work. But if you have 1/2, then this equals 3/6. Okay. Now, cross multiplication is something that we know Okay, so if we're to do cross multiplication here, we would say 1 times 6 is equal to, we do this cross, 2 times 3. Kind of cool, right? So 6 equals 6. If you're not believing me yet, let's try another example. 3/4 equals 75 over 100. Let's use purple here. All right, 75 times 4 is, let's see, 150 times 2, so 300. Oh, here, I should probably write it out. 75 times 4, which is 300, should equal 3 times 100. Okay, look at that. Feel free to try other examples if you don't believe me yet. And now I wanted to get into the logic behind it. Why does this work as a trick that we can do in math? Basically, essentially, if we cross multiply 2 times 3, it should equal 1 times 6. This gives us a tool, it gives us a way to determine an unknown. So if this 3 were an unknown, right, and okay, if this were x, then we could end up saying 2x equals 6, right? 2 times x equals 6. And that way we could determine that x equals 3. Simple algebra, right? Okay, so why this works is as follows. Let me see if I can explain this. Okay. If you have equivalent fractions, you're going to have something like a over b equals c over d. Okay. Now, if I wanted to isolate a by itself, one way we could do this in math would be to multiply this side by b, right? Simple algebra. Now, if we multiply this side by b, we have to do the same thing to this side, right? We're doing the same thing to both sides, therefore we can still say that this is equal. What this does is transform the equation now to a equals, because these guys cancel out, and now we have a equals bc over d. Okay, how do we get rid of that d on the denominator? In the denominator, well, again, similar to how we got rid of the b over here, if we multiply the denominator by itself, we have to do that on both sides, it will cancel out, right? So now we have a times d equals bc. according to our cross multiplication rules, A times D should equal B times C. That's it. That is how cross multiplication works. Try it out. See if you can find any numbers that don't follow this rule, and let me know.